Are you ready to learn physics?
Our first topic is about tension. It is common knowledge that you do not tie a string or rope or chain to an object to push it across the floor. Strings, ropes, and chains can only pull on things. The force of pull supplied by strings and ropes or chains is called the tension force. Formula: tension, force. The tension force is always directed along the length of the thing doing the pulling. String, rope, chain. When drawing a FBD, make sure that your tension force vector is drawn such that the object is being pulled and not pushed. And now, here are some examples of tension.
Bill Nye the Science Guy. Bill Nye the Science Guy. Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye the Science Guy.
T minus 7 seconds.
Our second topic is about force. What is force? Force can be defined as a push or pull. Technically, force is something that can accelerate objects. For example, when you throw a baseball, you apply a force to the ball. Force is measured by N or Newton. A force that causes an object with a mass of 1 kilogram to accelerate at 1 meter per second is equivalent to 1 Newton. When you slide your book on the floor, it will stop soon. When you slide it on icy surface, it will travel further and then stop. Galileo believed that when you slide a perfectly smooth object on a frictionless floor, the object would travel forever. Isaac Newton developed the idea of Galileo further. He concluded that an object will remain at rest or move with constant velocity when there is no net force acting on it. This is called Newton's first law of motion or law of inertia. Here are two opposing forces that pull on the rope in opposite sides.
Click, click, boom! I'm coming down on the stereo, hit me on the radio. Click, click, boom! I'm coming down with a new style, and you know it's buck wild. Click, click.
Here are forces the friction acts upon.
The following demonstration was conducted under extremely precise conditions. Do not, I repeat, do not attempt this demonstration at home.
The pull of gravity isn't so strong that we can't raise our arms or anything, but it does pull on everything all the time. So if we're standing on the Earth's surface, it pulls us down toward the center of the Earth. Now we can test this. This is an old idea, but a good one.
Our final topic is about collision. Collision of objects is a brief phenomenon of interaction with force of relatively high magnitude. It is a common occurrence in physical world. Atoms, molecules, and basic particles frequently collide with each other. An alpha particle, for example, is said to collide when the nucleus of gold atoms repel incoming alpha particles with a strong electrostatic force. The contact is an assessment of the event involving force of high magnitude for small period. The object of microscopic dimensions are said to collide, making physical contact like when a tennis ball is hit hard to rebound. Further, a collision involves forces of relatively high magnitude. To complicate the matter, the force during collision period is a variable force. It makes no sense to attempt to investigate the nature of this force quantitatively, as it may not be possible to correlate the force with the motions of colliding objects. Using force law for very small periods would avoid force analysis during collision. We must understand that a collision need not end up with change in motion only. It is entirely possible that a collision may result in the change in shape, deformation of the colliding bodies. Such changes resulting from force is not the domain of analysis of motion here. Here are some examples of collision.